Let's take a look at example 8 together. When I look at this graph, right, this function right here, we have f of x equal to -5 sine of x. I claim that this is odd, so I want to show that this is odd. Show f of x is odd. How do I do that? I use the algebraic definition. I need to show that f of -x is equal to -f of x. So I'm going to start off with my left-hand side. F of -x is equal to what? That's equal to -5 times sine of -x. But this is equal to -5 times negative sine of x. And this is true since sine is odd. And then we know that a negative times a negative is going to give you a positive. So this means we get 5 sine of x coming back. And you'll see that this is exactly the f function if I were to multiply by -1. So this is -f of x. Well, this is what the definition of odd means. You start with f of -x, you get -f of x coming back. So once you know it's odd, then this tells, you know what, maybe I could say even more here. I could say this is -5 sine x, just to make it perfectly obvious. So then you can see this is -f of x here. Okay. So all of this results in the following fact. Now we can say the integral from -pi to pi sine of, -5 sine of x dx is going to be equal to 0 by our theorem. Okay. So really the work is done in showing it's odd, because the result is just 0. Let's take a look at 9. And then if we have some time, we'll work on a couple problems. First thing I notice when I look at this guy, they have the same limit of integration above and below. This makes me suspicious. Maybe this inside part is odd. That's my hope, because then the answer would be 0. I look at this, the power is even. That's not going to be an odd function if the power is even. But this is just a vertical shift downward. So I have an even monomial here, and then I'm doing a vertical shift. A vertical shift isn't going to affect whether it's symmetric about the y-axis or not. So at this point, I'm like, you know what? I think this is even, but I got to show it. So what I'm going to do is I'm going to say, let f of x be equal to 3x to the 6 minus 2. I want to show f of x is even. That means I want to show, if I took f of -x, I just get the original graph back, the original function back. It remains invariant under reflection about the y-axis. So I start with the left-hand side. I got f of -x. That's equal to 3 times -x to the 6th minus 2. That's equal to 3 times -1 to the 6th x to the 6th minus 2. -1 to an even power is equal to 1. So that's just equal to 3x to the 6th minus 2. And this was the f of x, which is the right-hand side. So what have I done? I proved the definition of even. I mean, I used the definition of even to prove this function was even. Oh, sorry. LHS is left-hand side. RHS is right-hand side. Yeah. So what this tells me is that I can just take my integral. this integral is just 2 times the integral from 0 to 2, 3x to the 6 minus 2 dx. Now I just find the antiderivative. This is 2 times 3x to the 7th over 7 minus 2x. And we're going to evaluate that from 0 to 2. So let me bring the 2 in. That's going to give me 6 over 7 x to the 7th minus 4x from 0 to 2. And that's going to give me 6 over 7, 2 to the 7th minus 8 minus 0 minus 0. So we get 6 over 7, 2 to the 7th minus 8. Whatever that number is. Sorry. Okay. Any questions, my friends?
Oh, yes. So you plugged in a 1 just to test it, right?
What do you mean plug in a 1?
For into negative x. Did like 3 times negative 1 to the 6th power.
I don't see a 1. I see a negative x. Oh, this thing here. No, I didn't plug in a 1.
Oh,
I distributed. So if you have a times b to the n power, that's a to the n, b to the n. I was just trying to get you to see that if you take a negative number to an even power, it becomes 1. Like, if you could see negative x to the 6th is just x to the 6th, that's good enough. I think I over-explained.
okay. Why did you pull out the 2 and
Pull out the 2 there. Here.
Yeah.
That's the whole point of the theorem.
Oh,
The
okay.
whole point of the theorem says instead of going all the way, you can do half of it and then double the result.
Oh, okay, got it. Thank you.
Mhm. So it's kind of like when I showed you these examples of this even function here. Do I risk doing this again? I will. Let's go from negative pi divided by 2 less than or equal to x less than or equal to pi divided by 2. We get this. If we want to find the area under this curve here, instead of going from negative pi over 2 to pi over 2, I can go from 0 to pi over 2 and double the result because the graph is symmetric about the y-axis.
Okay. How can you
Mhm.
remember that cosine is even?
I know the graph of cosine.
Okay.
So any graph that's symmetric about the y-axis is even. In
Okay.
particular, cosine of x is even.